Sugod na ta!
Solutions of linear equations. Operations of matrices. We have the transpose of a matrix, determinant of a matrix, adjoint matrix, and inverse of a matrix. Transpose of a matrix is an n by m matrix that is formed from the original m by n matrix denoted by a raised to t. If A is equal to A11 to AMN, then the transpose matrix of A is equal to the first row of your matrix will become the first column of your transpose matrix. The second row of your matrix will become the second column of your transpose matrix. The mth row of your matrix will become the nth column of your matrix. Determinant of a matrix is a scalar quantity calculated from a square matrix. If we have a 3 by 3 matrix, then the determinant of A will be equal to, first, we will copy the first and second column of your matrix to the right hand side of your determinant matrix. Thus, we have now a 5 by 3 matrix. So the determinant of matrix A is equal to the summation of the downward diagonals minus the summation of the upward diagonals. So we have the diagonal A11 and A22 plus the diagonal A12 times A23 times A31 plus the diagonal A13 A21 times A32. Then we have minus the summation of the upward diagonals, that is A31 times A22 times A13 plus A32 times A23 times A11 plus the diagonal A33 times A21 times A12. So this would be the determinant of your matrix. Adjoint matrix. Let A be any n by n matrix, the matrix that is the transpose of the matrix of the cofactor corresponding to entries of A. Let's say this would be the cofactor corresponding to the entries of A. The transpose matrix of the cofactor corresponding of A is known as the adjoint matrix of A. Inverse of a matrix. Let A be any n by n matrix if there exists an n by n matrix such that your matrix A times B is equal to B times A is equal to I, where I is an n by n identity, then the matrix A is said to be a non-singular or invertible. The matrix B is said to be the inverse of matrix A. Illustration. If given an A and B matrix, thus if your A times B results in an identity matrix and your B times A results an identity matrix, then this shows that the matrix A is non-singular and matrix B is the inverse matrix of matrix A.